Welcome friends. Let us consider example on random variables. So the example we are considered is find the constant k such that the given function f of x is a probability density function. So f of x is given by kx square for 0 less than x less than 3 and it is 0 otherwise. Also we need to find these probabilities. Probability that x lies between 1 and 2, probability that x is less than or equal to 1, probability that x is greater than 1. Also, we need to find the mean and variance. Now, here we can see that the function is defined in the interval 0 to 3. X takes all the values between 0 to 3. It is defined in an interval that implies this is a continuous probability density function, and hence we have to take there the sum of all the probabilities means it is integration from minus infinity to plus infinity. If it is a discrete distribution, then we'll go for summation. If it is a continuous distribution, we will go for integration. Observing that it is a continuous distribution because it is defined in a range. Whenever it is defined in a range, it will be a continuous distribution. So the sum of all probabilities is 1. We know that is integration from minus infinity to plus infinity of the function is 1. Integration is from minus infinity to plus infinity, but function in the range 0 to 3 it is kx square. In all other range the value is 0. Hence we'll split this interval of integration from minus infinity to 0, 0 to 3 and then 3 to infinity. That is minus infinity to 0 f of x. So f of x in this range is 0. Again in the range 0 to 3 the function will take kx square, then again we'll take from 3 to infinity. Here the function value is 0. Sum of all these must be equal to 1. Now k is kept outside. Integration of x square, it is x cube by 3. Limits are from 0 to 3. It is equal to 1. Now x cube by 3 is there. Put 3 here. It becomes 3 cube by 3, or you will get it as 3 square here. So now it becomes k is equal to 1 by 9. Hence, we have the value of k as 1 by 9, for which this function will represent a probability density function. Now we'll go for the probabilities. Probability that 1 less than or equal to x less than or equal to 2. So it means it has to take all the values between 1 and 2. We'll take integration from 1 to 2 of the function f of x. In the range 1 to 2, what's the function? Now function is defined as kx square between 0 to 3 and 1 and 2 come inside this range. Hence we'll take the function as kx square in the range 1 to 2. K, you know, it is 1 by 9. Keep it outside. Integration of x square is x cube by 3. Limits are from 1 to 2. So substitute upper limit 2 cube, lower limit 1, 2 cube minus 1 divided by 3. Now we'll get the value as 7 by 27. Next is probability that x is less than or equal to 1. Less than or equal to 1 means it has to take all the values, that is from minus infinity to 1 will consider. Integration from minus infinity to 1 of the function f of x. But function is not same throughout the interval minus infinity to 1. Hence we will split this minus infinity to 0 f of x dx plus again 0 to 1 f of x dx, because we have the function kx square only in the range 0 to 3. In all other ranges it is 0. Hence we'll split it. Now again from minus infinity to 1 the function is 0. From 0 to 1 the function is kx square. So k is kept outside, 1 by 9. Integration of x square is x cube by 3. Now substitute the limit, upper limit 1 here, it becomes 1 by 3. Lower limit is however 0. So you'll get the answer as 1 by 27. Now probability that x is greater than 1. It is 1 minus probability that x is less than or equal to 1. 1 minus, already we have calculated probability that x is less than or equal to 1. Substitute it 1 by 27, you'll get 26 by 27. Or else Even you can write it as probability that x is greater than 1 can be written as integration from 1 to infinity. Here x should be greater than 1. So you can even take integration from 1 to infinity of f of x. Evaluate the integral. You will be getting 26 by 27. Now we need to find the mean. Mean is given by integration from minus infinity to plus infinity of x into f of x dx. So it is integration from 0 to 3 because function is defined only in this range. In other ranges it is 0 where I have skipped writing it. Actually you need to split minus infinity to 0, 0 to 3 and again 3 to infinity. But in other two intervals function is 0. So integration from 0 to 3 x into f of x. f of x is kx square. Now k is 1 by 9. We'll keep it outside constant. Integration of we have x cube dx. Integration of x cube is x raised to 4 by 4. Substitute your 3. Then simplify. You'll get 9 by 4. Now we'll go for variance. Variance, it is integration from minus infinity to plus infinity x square into f of x dx minus mu square. That's the formula. So again take integration from 0 to 3 x square into f of x is kx square in this range dx minus mu square. Mu is 9 by 4 already we have found. So minus 9 by 4 whole square. K constant 1 by 9 outside. Integration of x raised to 4. X square into x square is x raised to 4. Integration of x raised to 4 is x raised to 5 by 5. Hence the limits are from 0 to 3. Now substitute them. We will get 27 by 5 minus we have 81 by 16, that is mu square value. Simplify it, we'll get 27 by 80.